Have you ever been forced to watch one of those annoying IT security awareness training videos? You know the ones. The ones that warn against not using public Wi-Fi while logging into your bank or not giving people your social security number. You know the ones. The ones that are just meant to inconvenience us. Well, all you want to do is figure out how to click past the certificate warning on the Starbucks website so you can buy your $50 latte. Well, if that is you, then this isn't the video for you. On the other hand, if you want to see why maybe you should listen to those people, let me introduce you to my friend and any pen tester worth their salt's friend, Wireshark, the world's leading packet analyzing tool. In the tutorial ahead, I am going to do my best to guide you step by step through the necessary training to build a solid foundation in Wireshark. Now, just a heads up that I created this video for anyone eager to expand their knowledge of Wireshark. But I do have to say, the focus is going to be on Wireshark's practical uses in penetration testing. It's not going to be a deep dive into everything Wireshark can do, because frankly, that would be overwhelming and that would probably turn a lot of you off and you would say, what the hell is this? I don't want to watch this. Just like a lot of the videos on YouTube, frankly, do when you're watching a when you're watching a Wireshark video. It's a lot. It's overwhelming. I'm going to try to break it down into manageable pieces that we can at the end put it all together and take something away that will be, I would say, beginner to intermediate level concept and techniques. I will be posting higher level concepts in the future. So maybe we think of this as part one of the Wireshark series. Now, last thing before I move into the guts of the video and get started on the fun, I have to throw the disclaimer out there that this is for educational purposes only. And hacking, including scanning with Wireshark without permission on someone else's network, is illegal and you will end up in jail. So don't do it. Don't be stupid. Don't end up in jail. Thank you. All right, let's get on with the video. All right, you made it through the disclaimer. So let's get into what is Wireshark and how is it going to help you with not only penetration testing, but pretty much any other role in cybersecurity. And you could even take it a step further and say almost any other role in IT. How can it help you? And the easiest way to explain what it is would be to compare it to where in a movie you see there's, like, let's say the FBI. The FBI wants to listen in on another person's phone call, so they tap the phone or they bug the phone, and then they can listen in on that conversation. Well, Wireshark is really similar, but instead of intercepting voices, it intercepts data packets that are traversing the network. It can then put all these packets together in what's called a capture that can be saved, it can be sent to other people, or it can even be looked at in real time. And the reason you'd want to look at it is because it can help you with network reconnaissance, it can help you with vulnerability identification, exploit development, and more. So if I were to sum up what it is and how it can help you, it would be it's a packet sniffer, which most of you have probably heard, that can assist with capturing and analyzing network traffic, which can provide you with insight into vulnerabilities, security flaws, and the most important thing for pen testers, it can help you find potential attack vectors within a system or a network. Now that you hopefully have a little more understanding of what it is and how it can help you, we're going to get started with the installation. And I'm going to show you how to install it on Windows, and I'm going to show you how to install it or open it actually, because it comes pre-installed on Kali Linux. You can also install it on any other Linux operating system, but for this video, I'm going to be focusing on Kali and a Windows installation. Okay, so let's get started with the Windows installation. All right, I am now on my Windows 10 machine inside my lab, and what you're going to want to do is head on over to wireshark.org. I don't know why it says downloads there, but you don't need that. Just wireshark.org, which will load this page to you. And then you're going to want to scroll down until you get to the downloads, which is right in the middle of it. And you're going to want to pick your installer. I'm going to do this, as most of you will if you're installing on Windows. You're going to get the 64-bit installer. This will be the same for Windows 11 or Windows Server. If you happen to be on a Mac watching this video, you could download, depending on your processor, either one of these, or if you are on a different Linux distribution other than Kali, you could download the source code and compile it yourself. So those are your options. We're going to go with Windows installer. We would download that, but being that I'm on a slow connection and I'm not certain if the machine's just mad at me because I haven't activated Windows or whatever, I went ahead and downloaded this ahead of time to save us time. So we have it downloaded. We're going to go ahead and run it as admin to get the install going. And this is going to be a very basic installation. We're going to pretty much hit next or OK to everything, or noted, I should say. So we hit next. Just leave all this as is for now. I'll go ahead and put a desktop icon. You can do whatever you want. Make sure to leave this checked unless you have another packet analyzer you prefer to be defaulted to open those kind of files. I'm going to go ahead and leave that. I'm going to leave the installation directory to be where it went to, the default. And then you do want to make sure you install the npcap as well. And go ahead and hit next. You do not need to install the USB pcap. So go ahead and hit install. Let it run, and about halfway through, we'll have to, agree to the terms of services or whatever. So we'll just let it do its thing here for a second. And here we go. We're going to say yes, we sign our life away, and then go ahead and hit install at this section. And it's going to go ahead and install itself, and once this is done, then the Wireshark installation will kick back in. And here we are. We're going to go ahead and hit next. And now it's telling us it's been installed. And now Wireshark's going to finish installing. And there we go. Go ahead and hit next and finish. And we are done. We can go ahead and put this in the trash or whatever you want to do with it. And we'll go ahead and open up Wireshark real quick. And then we'll pop over to Kali Linux to show you how to open it up from there. So go ahead and double click it. And as soon as you get it open, you're going to notice it's going to start watching your traffic here. So you should see, there you go. This is going to be the traffic on the default connection. So pretty cool already. Before we even do anything, you can already see that the installation is working. So now I'm going to pop back over to Kali real quick and show you how to get it started from there. And then we'll start going over the basic interfaces. All right, I'm back on my Kali box, and I am now going to show you the two quickest ways to get Wireshark opened up on Kali. Actually, before I do that, why don't I just remind you that you should be good and update all of your own software so you don't become a victim. So you'd want to run sudo apt update and let it do its thing. It will tell you how many packages. And wow, see, I haven't even been good. I should practice what I pre-try. I have 87 packages. And if I wanted to see what those were, I could then do sudo apt list. And as you can see, I have quite a lot. Yeah. So I'm not going to go ahead and install these because that would take forever, and we don't want this video to go longer than it's already going to be. But I will show you the command that you could run next to do the full install. So you do sudo apt -y full upgrade. You'd hit enter, and it would start the process. And as you can see, I have a burp suite. It's on the burp suite package right now, and it looks like it's at 49%. So I'm just going to go ahead and clear this out here, and I'll finish that later so we can continue on with the video. Now, the first way to open Wireshark, once you've done all the updates, and the upgrades are important because that way you'll be on the most recent version of Wireshark and it will match the video. And honestly, it looks a lot nicer than the default version that was installed with this version of Kali. So anyways, quickest way to get Wireshark open if you're at the terminal is type in the word Wireshark, as long as you're root. You want to be root for this. So you're good there, right? Cool. Go out of there, clear this out. And the second way you can do this, that's really easy. Go up here, go down to sniffing and spoofing, and just open Wireshark again. And after a minute or two, you should start to see all three of these, the loopback, any, and ETH0, all start to have a little bit of activity on them. We'll just give it a second here so you can see what I mean. Hopefully it doesn't make a liar out of me because that would be embarrassing. And there you go. So as you can see, now we have activity on it, and that's a good thing. So from here, we'll move forward with the video into going over the interface, all this good stuff up here, what it is and what you need to worry about and what you don't. And that's that. So let's get to it. All right, as you can see, when we open up Wireshark, it defaults to this page. You're going to get this landing screen, if you will, or landing page every time you open Wireshark, unless you either A, open up a PCAP file directly, like let's say you open up one from the desktop on Windows, it would bypass it and go straight into the capture file for you to analyze. Or I believe you can actually disable this screen if you wanted to, or change it to a different screen. But as anyone I've ever worked with always just leaves this here, because this takes you nicely to the interface that you want to start a capture for. In my case, I'm going to go with ETH0. You go with whatever you want, but I would suggest you go on one that is on the network you want to scan and analyze. Otherwise, you're not going to get anything. Second thing on this screen is what's known as the capture filter. That's going to be right here. And this shouldn't be confused with the display filter. The capture filter is kind of a preemptive filter that lets you filter out things ahead of capturing it. So it's like a filter before the filter in a way, if you will. So by filtering something out here, it will never end up in your capture file. This filter up here, the display filter, is kind of after the fact. You've already captured the data and now you want to filter it even more thoroughly. And you can click the little banner here and get some already pre-built in filters. So you do have to select, so if you don't select anything and you click on here and let's say you want to do IP, it's going to be red. Red is bad. That means it's a bad filter. You need to select an interface and then drop down. And let's say you wanted to do IPv4 only. You can see it's green. It's happy, right? Or you could do TCP only. So that's how you're going to want to do it. I'm going to leave this open because for our purposes today, I want to get as much data as I can so I can show you what you need to look at. And then all you need to do next to actually start the process is go ahead and hit the shark fin right here. And it conveniently tells you when you mouse over what it's going to do. So let's go ahead and get it started. All right, here we are in Wireshark. And as you can see, it's very exciting because there's not a damn thing going on right now. And the reason for that is a good thing, actually. I don't have anything going on in my network right now. So if I saw a bunch of traffic here going crazy, I'd worry. But that's not the case. I expect to see this. Now, if you happen to expect something different and you're not seeing it, chances are you are on the wrong interface and you want to go back and check the interface you're on. Or there could be other reasons, but that's going to be the likely culprit. What I'm going to do now is I'm going to go ahead and ping whatever you wanted, really. I'm just going to go ahead and ping Google's name servers a couple times to get us some data over there. I'm going to go ahead and go back to it now. And as you can see, it captured our ping. So we know it's working. And what we're going to get is now that we have some data here, you're going to get a couple more options. Before you only had the start capture button. Now that we've captured, we can stop it. We can reset it, which will allow you to reset the capture, pretty much delete everything that's here, but keep the interface so you don't have to select the interface again. Or you can do some of these other options, but to do those, you have to actually stop the capture. And once you do that, these become available. So if you wanted to go into the capture option screen, which we'll go into in detail later, or if you wanted to save, discard, or reload the file. If this were a pre-captured file, capture file, you could do that. For what we're doing, I'm not going to do that. Instead, I'm going to show you a couple other things you're going to need to know about. This is what I mentioned earlier, the display filter. This is where we could, and we will a lot. That's kind of the whole point of Wireshark. We're going to use this to filter out if we had thousands of packets, which kind of leads me to the next screen. This screen, or this list specifically, is known as your packet list, right? And if you click on one of these packets, it will load these two other screens or windows or sections, whatever you want to call them. I guess you could say this is your packet list, this is your packet details, and this is your packet bytes, I guess you could say. And then down below, you're going to get options that say how many packages are in the total capture file. And this will change as you filter out, which I will show you. And then up here, it's showing just ETH0 now. But if we were to save this, it would change to the name of the file. So that kind of gives you a pretty basic layout for what you're looking at. We're going to go into further into all this good stuff over here, the different layers of the OSI model and all that fun stuff. For now, I just wanted you to be aware, this is going to be where you're going to see all the packet list. This is going to be, excuse me, the details of each packet that you select. And this is going to be the bytes. So with that, let's move on. All right, so I'm starting a fresh capture here. And as you can see, it's very boring. So we're going to go ahead and we're going to run an Nmap Scan. And we're going to scan the devices on my network in this range. So we're going to go ahead and do that. While that's doing its thing, why don't we go, well, that was quick. We're going to go ahead and go to cali.org just so we can get some HTTP traffic in there, or HTTPS in that case. We'll go to Nielsen, the best website on the internet. We'll go to YouTube, which is a pretty good site. And we'll close it out by going to slashdot.org, which is a site I used to frequent all the time, and I still get there occasionally, but it's a great site. If you haven't ever checked it out, it's news for nerds. It's awesome. Check it out. So I'm going to close out of there, and then we'll just do a quick NS lookup to like nmap.org. Let's do google.com, and why don't we also do a trace route over there. 1 second until it times out. Good enough for me. And I think that should be plenty to play with. And as you can see, we have 6,000 packets, 6,700 to be exact. So I'm going to go ahead and stop it. And then we are good. So one thing real quick I want to show you before we get too far into analyzing some packets. Let's say you can see I'm down here at 6,781. This is annoying. What do? I scroll up. Do I try to move it up over here? What do I do? No. What you do is you hit Control and G, and you go 1. You want to go to packet 1, and you either hit Enter or go to packet. You could also have gone up here and just gone first packet, last packet, next packet, or go to packet, which will bring up that window. So that's a quick way to how to navigate the packet list. So now let's get on into the packet details. All right, real quick, just in case it wasn't obvious, you do have the ability to adjust these panes down here however you want them. If you wanted to see more bytes, you could move it over here. There's not much reason to do that. But if you wanted to, let's say you wanted to see less of the packet listing, you could scroll it up there. Or if that were the case and you really wanted to see less of it, you could just double click on it and it will take you to this window where you don't have the packet list at all. I personally don't like that. You can either hit the X up here or close. I like it like this, but to each their own, do whatever makes you happy. All right, so we have a bunch of packets here. And as you see, we change packet, we change frame number. That's always going to be that case. That's great, right? But what does all of this mean? So I want you to go back, and if you haven't looked it up recently, look up the OSI model, 7 layers. This is going to correspond with 5 of those layers right now for this packet. And we're going to start with the first frame packet, the frame from this packet. And that is going to be your physical layer. That's going to be where you're literally going to see your Ethernet interface. And if we move on to the second one, layer 2, which is going to be your data or data link layer, whatever they want to call it nowadays. This is going to be your MAC address and things of that nature. Moving on to number 3, we're going to get the network layer. This is going to be where you're going to get your internet protocol, IP, v4, v6, all that fun stuff. Scrolling on down here, we're going to get to, what is it? It's transport. We're going to get the transport layer, which is going to be your UDP, TCP, all that good stuff. And finalizing the layers here for this specific packet is going to be layer 5, which is going to be your, well, in this one it's DHCP, but it would also be HTTP, FTP, SMB, and yada, 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 and all that stuff. So those are what those mean. And as you go to different packets, depending on what type of packet, it will show a different amount of layers of the OSI model here. So if we go to this one, look, it's only showing 3. And if we scroll down here, it's showing 4. So you kind of get the point. You go through, and as you do, it will change depending on the packet. So that's that. That kind of gives you a general understanding of that. I'm going to bring this down a little bit because it's bugging me a little bit for some reason. I don't know why. Anyways, let's move on. All right, so we spent a little time going over what's in the packet list and what's in the packet details. We haven't touched the bytes too much, but we will later on. But for now, I think it makes sense now that we know how to go to a specific packet. But what if we want to find information in a packet and we just don't know really where to begin yet because we don't, we're new and we're trying to figure out things? The easiest way to start off is going to be either you can do a Control F or you can go up here and go find packet. So I'm going to do a Control F and think of this as a search. And you can actually search. You can either search, well, first of all, you have to change. You're going to get 4 options here. You're going to get the regex, regular expressions, string, hex, and display filter. You're going to want to use one of these two 99% of the time. I'm going to use string for this example. And then here's where you would choose what you want to search. So you can do packet details or packet bytes. I'm going to leave it on packet list for this example. And it is like it's case unsensitive at the beginning. If you wanted it to be case sensitive, you'd have to check that. So just FYI on that. So let's go ahead and search. What should we search for? let's search for one of the websites. Let's go to the website I like, slash.org. So we search for it and boom, we get a result, right? And it looks like a DNS query. So if we go into this and then we expand, go down here to layer 5, expand this and go down to the query, look at that, slash dot. It even tells you to type a record, which is pretty cool, right? So you go down here and yeah, there it goes, even more details. So that's how you could use that. So that's how the find command works. You could also, so let's say we wanted to search in the packet details, and let's say what would be something we could try to find here. Let's look for our IP address. So we go 10.02.4. It's going to bring it up and find it in the details. So you can see by selecting this information over here, it decides what area it's going to search. So that is how the find command works. All right, another helpful trick you can do. So this is kind of confusing. Let's say we wanted to be able to find this packet real quick at a glance. You can actually right click on it and mark the packet. You can of course do it up here, mark all displayed, unmark all displayed, yada, yada, yada. But that gives you a quick at a glance. If you were looking at 20 different packets and you wanted to be able to come back to this one real quick, you could just go ahead and mark it. All right, another trick you can do is if you don't like the way that the time is working here, this is kind of like it started the minute you started the capture and then it counts up until you get to the end of the capture. But if that's confusing or whatever reason, you have some options and you would go to view and you would go to time display format. And then you get all these different options. The most popular one other people do is going to be UTC time and of day, UTC date and time of day. Say that 25 times fast. Click on it and you'll see now we're getting the UTC, which you'd have to do the conversion depending where you're at, but at least you get a timestamp of where it was. So that might be more helpful than, there's the packet counter from the time the capture started to the end. Like if you were doing something and you needed to prove a time and day type of thing. So that's how you can change that. For us, I'm going to go ahead and change it back just because it's a little cleaner, I think. And that one, the default one would actually be second since first captured packet. And then one thing that is kind of annoying once you do that, it does merge some of the column widths. So you might have to readjust. But anyway, let's go ahead and get to some actual filtering, because that's what Wireshark's really about. What I've been showing you is kind of how to navigate and some tricks to make your life a little easier, some quality of life improvements, I guess you could say, for those gamers in the audience. Now I'm going to show you actually how to get to the guts of the program. And to do that, I'm going to go ahead and I'm going to go Control G up to the top here. And we're going to start from the top. All right, we're going to start off with one of the easiest filters to use and one of my favorite filters to use. And that is something known as the Apply As filter. And that allows you to, when you're not 100% certain of what syntax you need to put in here to set up that filter, you can actually right click on one of the packets. Let's just go to this one. This looks good. And then you need to pick a column, because when we right click, we're going to do Apply As filter and we're going to do selected. When they say selected, they actually mean the column. So if I were to, right click here, let's say we wanted to apply a filter for all packets that had this IP as the destination. I think I said that correctly. So we'd hit selected and boom, all packets, 204 of them out of 6,700 that have this destination IP are now all we're seeing. Now let's say you wanted to take that a step further, right? Let's say you wanted to know also the info. You wanted this to match up. So what you could do is you could go down here and you could actually click on it again and go Apply As filter, and you would say and selected. And it would now throw in the and it would put in Cali.org. So it is claiming there's only one packet in this whole capture that went to Cali.org. And as you know, or queried Cali.org. And as you know, we only went to Cali once. So this is probably going to be accurate. So that, in a nutshell, is going to be your Apply As filter. You could do the same thing. Now you're down here. Again, you wanted to sort by this destination. Apply As, selected, boom. So all the packets in here are going to be from that. And it looks like there's only 32 of them. But you could take it further again and say you wanted to know now only when they were using this protocol. So you could right click this go to apply as filter and selected. And now you're just seeing the destination here with this protocol, TLS 1.3, which is actually the most recent and secure protocol. If you see this as 1.0 or 1.1, that's a target. But anyway, not to go down that rabbit hole. So as you can see, that's how that works. So apply as filter is pretty cool, and we just scratched the very surface of it. So remember, when you want to go back up when you're done, what do? Control G, we go 1, and we go back to the top. And taking it from the top, we are going to meet apply as filter's little brother. So what you're going to do is you're going to right click here and you're going to go prepare as filter. So very similar to apply as filter, they are related, family. But instead, when you select prepare as filter and do selected, it's just going to put it up here. It's going to put the filter in for you, but it's not going to execute it. To execute it, you would need to hit enter. But it works other than that the same. You can do, again, let's say you wanted to know this is the source IP. You could do apply as filter on the source. Boom, there you get it. And then let's say you wanted to know, there's not much fun in here, huh? Let's just say we wanted to know, we already did Cali, we'll just do YouTube. And you can do, again, prepare as filter, and you can do selected. And again, it doesn't execute it until you either hit enter or click on that. And there you get it. So again, very similar to apply as filter, but it's handy when you actually want to look at what it put up there before it executes it. So that's that. All right, and my Wireshark just crashed on me. So we lost all of our capture file because, like a noob, I didn't save it. But that's okay, because what I want to show you next is going to work better with a cleaner capture file here that we don't have to sort out yet. So what I'm going to do now, I'm going to just go to one website. What should we go to? Let's go to, how about linux.org? Okay, so we're going to do that, and we're going to close out. That's all we're going to do, and then we're going to stop our capture. And then we're going to do Control G to go to the top of our capture. And then what we're going to do, we're going to save it so I don't lose it again. We'll do linux.org.p. Actually, it should do that on its own. And there we go. All right, so we've learned the prepare as filter and the apply as filter. And that's great if you wanted to, you wanted to apply a filter that said this is the source IP, that's all you care about, or destination or protocol, whatever. But those are just single individual packets. What if you wanted to follow an entire conversation or transaction, if you will, from the time, let's say, we opened up Firefox and browsed to linux.org to the second we closed it out? What if you wanted to follow that from A to B? That you can do. But what if you wanted to be more specific? Because that's kind of what this capture would be. This would be all of that conversation. But what if you wanted to specifically follow, say, just the TLS interactions, or at least this part of the TLS interaction? What you could do is you could then go here and go to the conversation filter and put TCP. Now what this is going to do is this is going to follow all the transactions that took part at the beginning when the certificate was being checked. When we were communicating with the site, you could see we were the source. Here's the destination. We go back and forth, back and forth, back and forth. And you can dig further if you'd like to. You could actually go and say, let's look here, scroll down here. You can see it's TLS 1.2. You can keep scrolling down a little bit more. You can see the cipher suite. You can really go down. We don't want to go down the rabbit hole right now, but you could if you wanted to. You could even see the certificate length and stuff like that. But we're not doing that. The point I was trying to make is you can follow the conversation, which is pretty cool, right? Let's say you care so much about TLS, you wanted to worry about the DNS, this specific DNS conversation between us and this IP. You would then just go conversation filter, UDP, and we're going to get the conversation filter again. So we're querying here. You can see the response, or I guess this is a query and a query, and then we're going to get the response and the response. So that's what the conversation filter does. And again, you look at this site's using TLS 1.3. You could do the same thing. You would go conversation filter, and there's a lot more going on here. Again, you could go through and you could look into more detail. But I'm not going to get into that right now. I just wanted to show you what the conversation filter can do. It's pretty cool. All right, and not as cool as the conversation filter, but pretty cool, is a close relative that can actually, instead of filtering, let's say you just wanted it to be, like you wanted it to stand out, you can actually do something that's called colorize the conversation. So you could then go here, go to UDP, let's pick green. I think that should stand out. Click green, and then all the packets of that conversation are now going to be green. So then you could come down here, or let's just go back up here. You could go up here, go here. You could say, I want to colorize this conversation, and I want to make this purple. So now you can see that. So it does the same as the filtering, but it doesn't filter it. So you still get to see your entire capture here, but now they're colorized in individual conversations. So pretty cool. All right, now that we've kind of covered the standard or basic menu-driven filtering options where you can do, apply as filter, prepare, we just went through it. I don't really need to go over that again. I wanted to take a quick look at the statistic menu. And to do that, I am going to need to get a new capture file because I want to get a lot more information than we have here. So I'm going to start over with a new one. So we're going to start there. I'm going to go ahead and I'm just going to run another Nmap scan here. Actually, I don't know what happened now. That will just make this work here. And instead of that, why don't we just go ahead and do 10.0. And let's just go, we'll just go the whole range for fun. And we'll do that. We'll put that down there. And then while that's going bananas, we will actually go out here and we'll go ahead and browse to, let's go to Ford.com, just to get a couple random websites. And let's go to Toyota. They make good cars. Toyota. And since I'm a big fan of SpaceX, let's go there. And what else could we do? One more. Let's just go to, how about, let's see what happens if we go to Twitter.com. And look, it's still there. Okay, so, just kidding. So go ahead and we're going to close out of this now. And then let's go ahead and check on our little Nmap here. It's still doing its thing. So while that's going there, let's go ahead and open up another one. And let's just go ahead and real quickly ping that. Let's do an NS lookup of, what do we say, gmac.com. And let's do a telnet over here. And actually, let's do that, and we'll see what we can do. We can say actually, here, let's do this. Root password. That would be awesome if that worked. Okay, just to show you what we can do with that later. So let's get out of here. All right, I think this is sufficient. We don't really need all that. So we'll let this catch up real quick. What do we got? Okay, we got 22,000 packets, so I think we're cool here. So I'm going to go ahead and stop this capture. And before I lose it, I'm going to save it. And we'll go ahead and name it as stats. We'll just name it stats. All right, cool. All right, so let's go ahead and look at the statistics menu. And the first one I want to show you is the resolved addresses. And at the first glance, you're probably like, well, that looks obnoxious, which it is. So what you want to do to make this a little more pleasant on the eyes is drop down here to hosts. Now this is going to give you either the IPv4 or 6 address, and then over here it's going to give you the host name in a nice human readable format for the most part. Now how you could use this is you could scroll down. If there's anything unexpected in the capture, like you're like, whoa, why am I resolving that address? There shouldn't be that in this capture because I don't remember doing that. You'd want to investigate that further. Technically, you probably could also find rogue devices in here that shouldn't be on your network, but I'm going to show you an even better way to find those devices in a minute. So let's go ahead and look at another option. All right, let's go ahead and look at protocol. Or should we do conversation? Let's do protocol real quick. All right, so protocol is exactly what it sounds like, a breakdown of the protocols. And how this can be really useful is all of a sudden, let's say you're looking at this and you're like, oh my God, why is there telnet going on in my network? I shouldn't be using telnet, right? Or the people that you're running a pen test on shouldn't be using telnet, right? So what you can do is you can now right click on this, go apply as filter and hit selected. And now what it's going to do is you're going to go back to your capture and it's going to be just the telnet traffic, which is really helpful. Then you could, again, investigate further, which I will show you in a little bit. So let's just clear out of that. So that's what the protocol hierarchy. I always forget that. That's what that's going to do for you. So let's go ahead and look at the next one down the list. And that's going to be, if I can find it, where am I going here? All right, so we're going to conversations. All right, and when you come in here, you're not going to want to really pay a lot of attention unless you have a need to be looking at layer 2. You would want to go over here to IPv4 or 6 if you had some v6 traffic in there. We don't. So what you're going to do in here is you're going to notice you're going to have address A and B. That's going to be like your source and destination, or whatever you want to say. And then you're going to have your packets and bytes combined between the two. And then you're going to have your A and B bytes and packets, and B and A. And you can see the arrows are which way they're going. Pretty self-explanatory. Same thing for the protocols. You can actually go in here and you can see address A, what port, address B, what port, and then you can sort. So you could see, okay, address B, you could scroll down and you could look for, let's say, a known port. What's a known port? We could look for 53. Okay, so what's going on here? Some kind of DNS query probably. And you could take it further. But over here, you could actually say, okay, I want to know where's most of the traffic. What's sending the most traffic between us and them? You go in here and you can look at this and say, okay, it looks like this guy. Looks like this guy, which is our default gateway. So that would actually make sense. I'm surprised that's not more. And then this. So then you would take it and you would investigate it a step further. I was going to say you would step it, but you would investigate it a step further. Again, and we could go into this more deep detail, and you do have the capabilities to right click, apply as filter, and you could have it be a filter. That will be in part 2 or part 3. But we'll stick right here with part 1. And last one I want to show you is endpoints. And this is very similar to conversations. You're going to notice the menus are identical. But the difference is here, you're not going to see A to B traffic. It's just going to be A, if you will. And you could then, let's see, at a glance, you wanted to know what was sending the most data across your network. You could then sort and go, okay, why is this sending 32? And this is only sending this, or vice versa, or what's sending the most packets, or, so you could come in here and look that way. So pretty helpful, especially if you're looking for like rogue devices and you don't want to deal with the extra back and forth view that conversations brings you. That's probably where you want to use that. So, all right. And the last 3 I want to show you real quick are all kind of related. Well, not necessarily. The way they function is, so we're going to do IPv4 statistics. Let's just do all addresses. This is going to give you the statistics of all addresses. Really similar in a way to conversations, but this, or endpoints, I mean. But this is going to give you a little bit more. It would actually show you like burst rate, burst start, and all that. And then there's, of course, you scroll down here, what you probably saw is DNS. And this is kind of helpful. So you wanted to know what kind of DNS requests or queries were going out. You could actually look and say, oh, 14 PTR requests or queries or A records. So that's kind of helpful. And then the last one I'll show you here is you can actually do HTTP if you wanted, and you could do like HTTP requests. And you can see, we made a request for Toyota, or I don't know, you scroll down, you were watching. We made a request for Ford, and so on and so forth. So it's kind of cool if you wanted to. Now there's a way to do this with a filter, but that's kind of the easy way if you didn't want to have to remember all the filtering syntax and all that. But I'm going to teach you next, right now, as we near the end of this video, what those filters are and the most used filters you're going to need for pen testing right now that you would actually do from the display filter. So let's get to that. All right, and I've gone to the top of the packet list to do our first filter. And the first one I want to do is one you will use a lot probably. It's going to be ip.adr, and actually it's pre-filled down here, but we could then search for any IP we want. But you know what, 13 is a box that we're going to play with later, so let's go ahead and search for that. So what this is going to do, it's going to look for the IP address 10.02.13. So its IP address equals 10.20.13. Now the thing is, this is not telling it that it's the source or the destination. It's just telling it to look for that IP. It doesn't care if it's source or destination. So if you scroll down, it looks like right here, right, they're all under source. So you could assume, okay, they're all going to be the source. No, but if you scroll down, and I'm sure there we go. So eventually now it's the destination, and look what's the source. So again, it's looking for that, doesn't care if it's source or destination. And I think that's actually one of the trick questions I put out. on one of the questions was, how do you find the destination? And I think I had put this in as one of the answers. So if you pick that, you're wrong, and that's why, because it could be either or, right? So now let's say you wanted to take that a step further and you wanted to do a range. All right, before we got into the IP range filtering, I wanted to give you a quick heads up on the options you have for your comparison operators. And obviously, as you can see, you have equal than, which we've used, and you have not equal, greater than, less than, greater than or equal to, or less than or equal to. So I just wanted to give you an FYI, because as you see me moving through the next filters and I'm doing greater than or this or that, I didn't want you to go, well, what the hell do those even mean? So if you ever need to, you can always come back here and see it. So now let's move back into the IP range. All right, and for a range, we're gonna do something really similar, but instead of equal, we're gonna do equal than or greater than or equal to 10.02.4, right? And we need to add on the word and, of all things, right? And then you're gonna do IP address, and then we need to put in less than or equals to 10.02, how about 15? So now what we're telling it is we're looking for the IP addresses that are greater than or equal to 10.02.4, so anything higher, but anything lower than this address or equal to. So pretty much anything between 2.4 and 2.15, right? So you go ahead and enter, and that's going to bring up anything in between. And I know some of you are probably like, well, look, that's over there. That's not in the range. It doesn't matter. It's looking for one or the other. Now, if this was some random IP address over here, like 10.20 or 10.0.2.2, and this was the destination, it wouldn't show up. But this is going to be either of these addresses in either section. It doesn't care what the other part is. So that's how you would do that. That can be helpful if you wanted to search just a specific, like a segment of a subnet or whatever it would be. So let's look at that. You can also do a filter by a port. And to filter by port, all you need to do is go up here and do either TCP.port, or you could actually do UDP, whatever you wanted to do. We'll stick with TCP to start. So TCP, and let's pick a port. We can do equal to, greater than, or less than. We'll do equal to, and let's search for port 80, right? HTTP. And as you can see, there's a lot of it. And right over here under the info, you can see the port. And that's that. But what if you wanted to search for port 53, TCP? How's that going to work? Not very well. So what you'd need to do then, remember, okay, I'm looking for something that should be UDP, not UDPO, UDP. Hit enter, and this is going to work nicer for us. And there you go. You can see port 53 is going to be our friend DNS. So that's a much better result than when we're looking for TCP. So that is how you would do the port, specific port. And taking a step back to IP, and I actually meant to do this before I showed you how to search for specific ports. We need to know how to do IP source and IP destination, right? So to do it, super easy. You're just going to do IP.src for source or DST for destination. That's all there is. So we do IP source equals or whatever, like I just showed you. And let's do 10.02.4. Actually, let's do 2.13. And if you go ahead and enter, you're going to get anything where the IP source is 2.13. Now, what you could do here, you can actually then do and IP DST equal 10.02.4. And then you're going to get any time those two match, source and destination. So like when we first started, I don't even know, 20 minutes ago, when we were right clicking and we were preparing the filter as, and adding and selected, this is very similar, but we just typed it in, right? So that's how you would do it. Now you could actually, of course, do IP source or destination first, or source. It doesn't matter. So just an FYI, that's how you do that. All right, and just as you can filter for source and destination IP addresses, you can actually filter for source and destination ports, meaning show all the TCP packets or UDP packets originating from a specific port. Now, this can be very helpful when, let's say, you think maybe you have a rogue device that's sending email out, SMTP, and you wanted to search for port 25. Anything originating from port 25 should be a red flag or things like that of that nature. So that's how this could be useful. And to do that, you would simply go in and you would do like, so we'll just do port 80. So we'll go tcp.src port equals, and we'll do 80. And that's great, right? All right, so that's the source. And if you wanted to do destination, like I said, just to show you that it actually does work, you would just do that. And again, you could combine this and say, and, or you could even do and you could go IP source equals 10.02.4, hit enter. So now you're gonna get anything from me going to this destination, port 80. All right, now I wanna show you what's known as application level filtering. So what we can do is we can actually use the application layer of the OSI model and search for things such as HTTP. Cool, right? There's all the HTTP traffic in the entire capture file, and it looks like we're getting 98 packets. So not that much HTTP. We weren't on it very long. But you can actually take this a step further. Let's say you wanted to know, I don't know, anything that used the request method of get. So you hit that. Come on. And then you get that. All right, so you're going to get the request, any HTTP get requests, or you could do the opposite and do post. And it is case sensitive. You have to hit enter. You would get that information. Pretty neat that you can do that, right? So you can actually do the same. Let's say instead of HTTP, we wanted to know DNS. And now we're getting all the standard DNS queries. And you can, there's even a lot, and I'm not going to go into it, but you can actually do QRY, and you can take it a step further, and you can even put like type. And then if you knew the type, I don't even know what type is what off the top of my head, but let's just do one. So what does that look like? It looks like it's going to be an A record. So if you wanted, and you could go and look this up. I apologize again, we weren't going to go too crazy, but these are the things you can do at the application level protocol filtering. So it's pretty powerful what you can do there. All right, and one more you can do here. You can actually filter by packet size if you wanted, and it's super easy. You just do frame.len greater than or less than, whatever you're doing. And let's just say 20,000. That's a pretty big packet, right? Wow. But there's still 71 packets that are at least 20,000 bytes. It's more than I would think there would be. And it looks like, are they all TLS? Yes, they are, which I guess kind of makes sense because there's a lot of overhead with encryption. So that's how you would do it by size. All right, that is going to be the final demonstration I wanted to go over for filtering. At this point, you know, being almost 50 minutes deep into this video, I would like to laterally pivot to something different. And what I'd like to do is show you a couple examples of some techniques you can actually use that kind of incorporate all the filters and the stuff we covered in the previous 50 minutes of this video and kind of put them all together and do a couple cool things. So that said, let's go ahead and pivot over there. And to do that, we're going to start with a clean filter. So let's do it. All right, and the first thing I want to show you is why you should not, first, A, use public Wi-Fi, B, ignore certificate warnings like our buddy at the very beginning of the video did. So to do that, I am going to go over to a different machine, not Kali, and what we're going to do over here is we're going to go up and open up a web browser here. And we're going to make this bigger so you can see what we're doing. And we're going to go over to our overpriced lattes right here, right? Which is starbucks.com, right? Totally, this is believable. You know, that looks like a Starbucks logo, doesn't it? So what we're going to do is we're going to try to log in with, you know, let's just do overpriced latte. And we're logging in. We can't get in. So we try again. Overpriced latte. And we just can't get in there, right? So we're like, damn it. Okay, so we're pissed off. And let's just say, okay, well then if we can't get into Starbucks, we might as well go over to our favorite website, douchebag.com or douchebag.org. Okay, well, we're there. We're going to try to log in there. And we're admins over here. So we're going to do our admin login. No, wait. Oh, we can't get in there either. Is the password yes? Nope, doesn't work for me either. So, okay, we can't even get in there at all. So, okay, well, whatever. Let's just go over to Nmap because we like Nmap and we want to search for something on Nmap. I don't know, let's search for how to port scan. And, oh, it's broken. Damn, nothing is just working for us today. So what we're going to do instead, we're just going to go to our last little bookmark over here on, we're going to try to get an FAQ on what we did wrong. So let's just go ahead and search, and as you can see, this is down here, an actual Google embedded inside here. So we're going to go, what did we do wrong? Oh, look, you're actually getting results here. Where did we go wrong? What did we do? That's not exactly what we want. So now that we've done all this, on a public Wi-Fi network, let's go to our Kali Linux box and see what it was able to find out. All right, and back over here on the Kali Linux box, we got 3,600 packets, 3,600 and some change. A lot of packets for the few minutes we were actually running the capture. So what we're going to need to do is we're going to need to filter out some of this junk. So to do that, we're going to go ahead and start with an HTTP filter. That immediately reduces our packet count down to 134. Pretty good, right? But we can make this better. And what we're going to do that, we're going to combine by using the AND statement, or you could do and we're going to say IP source. And I happen to know the IP of that machine because it's actually, imagine I'm in a private network performing a pen test, and I've set up this dummy, site for these people to go to. And of course they fell for it. So now what I'm doing is I am now entering the IP of the machine that I know the victim was on, and I'm going to go ahead and enter it here so I can filter out everything else except for HTTP and that machine. And I do that, and it brings me down to 70. So now we're pretty good. You could get a little bit further here if you wanted to actually search for HTTP post, because that's what we're going to be looking for. But rather than do that, why don't we just scroll down a little bit and I can show you what else you get in it. So actually, here's the first one. You can see this is the website. You're going over and you can actually see here's the GET request. And as you come down, here's the post. And the post is what we're looking for, because the post is going to contain the information with what the user posted when they hit enter or submitted to that website. GET brings it down, post puts it up. So as you scroll down over here, you're going to notice, and these will probably not be expanded, but they happen to be for the video for some reason, which is kind of a bummer because you just saw the surprise. But when you come down here, you can actually see the form fields, meaning the fields that said username and password, and then the login is just the login button. And you can see here's the username they put in overpriced and latte. Okay, so that didn't work. They go down here and then they put in another username and a password. And you scroll down here and you can see is overpriced and latte with a 3 instead of an E, because they're obviously hackers because they used LeetSpeak. So that didn't work either. So they got frustrated at this point, and you can see at this point they're going over to a different website. And at this point, they are again going to post their login information on douchebag.org. And when you scroll down here, here you go. Here's their login information, admin. But that didn't work. And they got upset. And they, instead of thinking, wait, maybe there's something wrong. Maybe that warning I like clicked through earlier, maybe I shouldn't be posting my password. No, that wasn't good enough. So they tried again. So now you have 2 attempts. All right, so at that point, they decided they had enough of that. And as you can see, this was in my internal box. But at this point, they have now decided, okay, we're going out. We've had enough of this. We're going out to another site. So they go out and they head out to Nmap, scanme.nmap.org, because they wanted to know how to port scan. I don't know why they wanted to know that, but conveniently they wanted to. So we're just looking for the search field. And what do you have in the search field? How to port scan. Interesting. And look, how to port scan. Okay, so we can see everything they put in that search, but they weren't done there. They haven't done enough damage. So now they go to a completely new website all the way down here on FAQ results. And again, they're doing another search here. And what they're doing here is they are doing another search. And if you look at the query right here, you can see, what did we do wrong? Oh my God. And this was an embedded Google search. So there you have just a brief example of what could happen, if, let's say, again, you're doing a pen test and you have a client employee
who ignore certificate warnings on websites. Or let's say this wasn't a pen test and this was some, this was a bad actor out there in a Starbucks and some guy was ignoring it and he actually going to a website and then right there he would be compromised. So that's just one reason why in the beginning of the video, I kind of laughed about it, but there's a very big reason why you hear don't use public Wi-Fi. Especially don't do anything you don't want anyone else to know about over public Wi-Fi. I would just not use it. But that's one reason why. And that's one reason why knowing how to do some of these filtering techniques in Wireshark is extremely powerful for not only pen testing, but also pretty much the whole entire IT industry. So with that said, I now want to move on to another example. Before we get to that, I wanted to take a moment and just ask that if you are enjoying this video, please give me a thumbs up. I really would appreciate it. It helps the channel out. And it just shows that I'm doing well and that this content is stuff you're enjoying. And of course, if you didn't want to miss future content, go ahead and subscribe. And if you wanted to go wild, go ahead and hit the notifications. And last thing I just wanted to mention also is I did start up some channel membership tiers and I started a Patreon. So if you really wanted to show me some support, you could, sign up for a membership or Patreon. And right now I don't have a lot of perks up there, but in the future I do plan to put, early release videos for the members. I'd like to put some practice tests for certain certificates that I'm going to come together more instead of just 1 or 2 questions. I'd actually put, 90 question practice exams or whatever the actual exam would be for that certificate. Just some ideas and even more than that, but those are just a couple things I'd like to mention. So if you wanted to do any of that, from the thumbs up all the way to becoming a channel member, I would greatly appreciate it. All right, with that said, let's get on to our next demonstration here. All right, I just started a new capture over here on the Kali box, and I'm going to jump over to my Ubuntu box here. And what we're going to do is we're going to go ahead and run an Nmap Scan so we can see what it looks like in Wireshark to have that an Nmap Scan performed against us. So that way I can help pretty much anyone, but especially system administrators and cybersecurity experts, know what to look for. So you can know if you happen to be getting poor scanned. So what we're going to want to do is we're going to want to run an Nmap, and we're just going to want to do an S and uppercase T here, and I'm going to do it across, the whole network. So again, we're going to go there, we'll let it run, and we'll jump back over to the Kali box. And as you can see, it's gone a little bit crazy here. So we're going to let it just go for a couple more seconds. I'll go ahead and pause the video and come back when it has calmed down. All right, so it calmed down. So I went ahead and stopped the capture. Now I'm going to go up to the top. And what I want to show you now is while running Wireshark, when someone else or another machine out on a network runs an Nmap Scan, I want to show you what it looks like on different machines. So first I want to show you what it looks like on the Kali Linux box, which is a pretty secure machine. I don't think I have any open ports on it. It's pretty hardened too. So we're going to go ahead and put this in, which is going to be IP destination, which would be the Kali box, because remember, the other one is the source who's scanning us. So we're going to want to go ahead and hit enter here. And there you go. We get the results. And you can see down here, we have about 1,002 package, which makes perfect sense because Nmap, with the scan we did, it usually does 1,000 ports, a default 1,000 most used or whatever ports. So for some reason, we're getting 2 extra packets in there, but that's fine. But when we look at it, you can see here is the Nmap Scan, and it's scanning literally port 80, 110, 993, 888, and so on and so forth. And it just keeps going down and down and down the list. But what's important here, you can see all these ports are closed. And you can see that because it's running the synchronize here, but it's not getting an acknowledgement. It's just a one-way. It's not like it's the first part of the 3-way handshake or whatever they're calling it. 3-way handshake, yeah. So it's the first part of that where they're just kind of fishing to see if they'll get a response. And this box was good and did not give any responses. So that's great. Now, what if we go over and look at a different machine? And let's look at 13. All right, so here we are, we're over on 13, and you can immediately see there's a lot more going on here, right? You can see there's some reset packets, some acknowledgement. So let's say we wanted to follow, and we'll just go with this one, I guess. So this looks like it was reaching out on port 80. Now, if we were to right click here and go follow TCP stream, get rid of this annoying box, you can come up here now, and what you can see is, okay, so it reached out, it sent, synchronized, and looky here. we then responded. Well, we didn't. This box responded with the synchronize acknowledge, and then this one responded. And at that point, you have completed the three-way handshake. So you now know port 80 is definitely open. And then it went ahead and reset it here. And you can continue on down the path. What happened? Oh, I cleared the filters. Duh. Let me see if I can get that back up there. Okay. And you can continue on down, and you can see that for multiple ports. So let's say we wanted to look right here, and we do the same thing, and we go follow TCP stream, and you'll see it again. Synchronize, acknowledge, boom, 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 three-way handshake. So you can see that port's going to be open as well. And whoops, and let's not clear the filter. Actually, I think we're going to have to, because it got rid of the original filter when I did that, which makes sense because we told it to follow the stream. So anyways, you can kind of see that's what it's going to do. And that's how it would look on a machine that actually had a bunch of open ports. So you could go down there and just see what was open and what wasn't. But more importantly, if you are, the system administrator and you just happen to be running Wireshark because you feel like there's been, maybe there's just been some like latency on your network, or maybe there's a broadcast storm and you're trying to identify that, or a rogue device, and you just happen to go in here, and then all of a sudden you notice this is going on, that is going to be a big red flag. That is time to isolate that subnet that's being scanned and track down what is going on. Because if you notice all those ports getting scanned and you didn't authorize anything, big problem. So that is what I wanted to show you here for what an Nmap scan looks like. And with that, I think I'm pretty much going to call this video complete, because we are now over an hour in length. And I think this might be the longest video I've ever created. And yeah, I think we're good. So hopefully, with that said, you have learned a lot in this video. You have now gained at least a fundamental understanding of Wireshark, its capabilities. And in the next video in the series, we'll take it a step further. We'll have a little refresher at the beginning, take it a step further, and learn some even more advanced and in-depth techniques. So I hope you enjoyed it. Again, if you did, go ahead and give me a thumbs up, subscribe, like it, do all that fun stuff. Other than that, have a great day, and I'll talk to you later.